Hello, welcome to PushCorp. I'm Isaiah Flora. Today we're exploring robotic polishing on metal tubes. Please consider subscribing to our channel. We're constantly trying new robotic material removal applications and we'd love to bring you along. Let us know in the comments if you have any questions around robotic polishing and give this video a thumbs up if you found it helpful. Our goal in this application was to automate the polishing operations on bent metal tubing. Since the part was symmetrical, we focused on processing half of the part. From this, we're able to show the customer how to process each type of feature, such as this inside corner, and provide parameters such as force, spindle speed, feed rate, and abrasives. This recipe will give the customer a baseline for the finish they can expect, which will ultimately de-risk the project. We fixtured the part to our table, then mounted an AFD 1240 and STC 1515 BT30 onto our 300 kilogram Kawasaki robot. The AFD 1240 is PushCorp's largest active compliance device, providing up to 215 pounds of force in any orientation that you position it. Its heavy-duty bearings were a great fit for the payload of the spindle and the force the application required. It provided a constant force throughout the whole process, which was key to achieving a consistent polish over the whole part. The PushCorp STC 1515 BT30 spindle mounted to the AFD 1240 provided 15 horsepower and a max RPM of 15,000. It was able to spin the buffing wheel at a constant RPM to help provide consistent results over the whole part. However, we monitored the current draw from the amplifier during the process, and we determined that an STC 0612 BT40 would be a better fit for the customer. Its torque curve is better suited at lower RPMs and allows the customer to size up the buffing wheel to reduce cycle time. The buffing wheel was a Norton fixed abrasive buff, or fab wheel. The wheel features abrasive grains within the wheel. We did use some compound to help keeping the part cool. The wheels are waterproof and tear resistant, giving up to 35% longer life than a traditional cotton buff. This makes them a great pairing for robotic applications. We held the fab wheels with a PushCorp BT30 tool holder along with some custom flanges. Alright, that's all the equipment we use. Let's check out the video. Off camera, we applied buffing compound and periodically reapplied it throughout the process. In an automated cell, this would be accomplished robotically. The key to programming this buffing application was to keep the wheel perpendicular to the tube. There was some room to angle the wheel just as long as the tube didn't start to slip between the flaps of the buff wheel. The force control provided by the AFD and the constant RPM from the spindle combined to give a consistent finish over the whole part. If you're interested in automating your buffing application, we'd love to help you explore your options. We also specialize in other material removal applications such as sanding and grinding. To get started, send us an email to sales@pushcorp.com. We'll also link a playlist with other material removal applications we've done in the past down in the description. Thank you so much for watching. We'll see you next time.